we're going to continue with our linear programming and optimization problems. And so first of all, what does the word optimize mean? So if you ever heard the word optimize in a sentence, what would it mean? To get the most out of something? Okay. Any other thoughts? Optimize.
Like to make something the highest like it can be.
To make something the highest it can be. Okay, and so in math, we kind of have a mathematical definition. It kind of goes along the same lines. You're seeking the best price or amount to minimize cost or maximize profit. So you're getting the most out of something, okay, making it the highest it can be. And so that goes the same here in math. And so that's what we're going to do. We're going to now look at a story problem that deals with that. So to optimize is to seek the best price or amount to minimize cost or maximize profits. And so if you look at the next slide, we're going to go ahead, and you already have this written down on your sheet. We're going to go ahead and look at that story problem there, and we're going to solve that by using optimization. And so first of all, it says each week Mary can make 10 to 25 necklaces and 15 to 40 pairs of earrings. If she earns profits of $3 on each pair of earrings and $5 on each necklace, and she plans to sell at least 30 pieces of jewelry, how can she maximize profit? So first of all, I'm going to start with the necklaces. And I'm going to let the necklaces equal X. And it says she can make 10 to 25 necklaces. So basically what that means is that X is between 10 and 25. So that is something that we looked at yesterday, okay, how we graph that. And so what I need to do is go ahead and graph that. And so what type of lines do I have? Vertical lines. Okay, I'm going to go ahead and draw in some vertical lines from 10 to 25. So I think what I ended up doing is I ended up letting each one be, gosh, was it 3? Let's try that again. Or 2. What do you want to let each one be? About 2? Would that work? Let's see, 1, 2, 3. Yeah, let's go ahead and let each one be about 3. And so 10 is going to be about 3 and about 1/3 of the way. Okay, so go ahead and we'll draw a line in. So 10 is going to be about 3 1/3 of the way. And then 25 is going to be about 8 1/3 of the way. So there's going to be about your 10 and 25. I'm going to actually move this over just a hair more. There, that's a little bit better. There we go. So there's your 10 to 25. So now what we're going to do is we're going to go ahead and shade in between that area. Okay. Now the next one says that she sells 15 to 20 pairs of earrings. So what does that tell me? Y. That tells me Y, exactly right. So 15 is less than or equal to Y is less than or equal to 40. Okay. So 1, 2, 3, 4, 5. So I'm going to go ahead and go up 5. Oops. Sorry, I forgot my pen there. And then 40 is going to be roughly about 13 1/3. And so we're gonna go ahead and shade in between there. So right now you should have a rectangle that's shaded in common. Now the next one says that she plans to sell at least 30 pieces of jewelry. And so what that tells me, if she plans to sell at least 30 pieces of jewelry, that means that the number of necklaces plus the number of earrings is at least 30. So can somebody tell me what kind of equation that's going to be, or inequality that's going to be? X plus Y is greater than or equal to 30. So in that line, I've got a slope of what? What's my slope on that one? Yep, -1. What's my y-intercept? 30. So I'm going to go up 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Slope of -1, down 1, over 1. And so then I'm going to go ahead and draw my line in. And so now I got to figure out where am I going to shade. So what way am I going to shade? I'm going to shade above. Yep. So, oh, gotta grab my pen, sorry. So I'm going to go ahead and shade up here.
Why would you shade it there?
Because 0, 0 doesn't work. If I plug 0, 0 in here, I get 0 to be greater than 30. And so then now, if you notice, I have some boundary points. Here is a boundary point. 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 And here is a boundary point. So all of those are boundary points. And so the coordinates of those, the first one is at 10. And then if you look at that, that's about 2/3 of the way there. So I've got 10. My first coordinate will be 10. What does that come out to be? 15, 18, 19, 20. 10, 20 will be your first point. Your next point then is going to be at 10, 40. Because that's going to be at the point 10, 40 up there. My next point over here is going to be at, what is that, 15, what do I have there? 15, 15, okay, so 15, 15. My next point over here will be at, what's that one, 25, 15. And then my final point will be at 25, 40. So those are your 5 points. Now the question is, what equation do we plug it into? So if you look in the original problem, it says she earns a profit of $3 on each pair of earrings and $5 on each necklace. So that's what you're trying to maximize. You're trying to maximize the profit. So what did we represent necklaces with, X or Y? X. So that would be 5X. What did we represent earrings with? Y. So that would be 3Y. So what I'm going to do is plug each of those 5 points into this 5X plus 3Y. So I need you to go through and do that. Tell me which one gives me a maximum profit. So remember, what I'm going to do is start with 10, 20. So I'm going to take 5 times 10 and add 3 times 20. So 5 times 10 plus 3 times 20. And what does that give me? 110. Okay, do the 10 and the 40. What does that give me? 170. What's the 1515?
Not 20?
What?
120.
120? What's 2515?
170?
170. Okay, and what's the 2540?
240?
What?
245?
245. Okay, and so, if she plans to sell at least 30 pieces of jewelry, how can she maximize profit? So how can she maximize profit? By selling 25 necklaces and 40 pairs of earrings, and that should make sense, shouldn't it? I mean, when you think about it, that should make sense. That's the most she can make in a week, so obviously that's the most money she can make. But that's how you go through and solve an optimization problem. That is the steps that you go through. So, I think I already gave this assignment to you, the 8 through 16 events. You need to get this done for Monday, okay? Done for Monday. Or actually, take it back, it's done for Tuesday since we don't have school Monday.